Alright, hello everybody. My name is Seokhyun, and I will be creating some videos to help prepare you for the AP Physics 1 exam. And today I want to talk about the fundamentals of physics, which is vectors and what they are, how to distinguish them, and how to deal with them, and etc. Um, let's first start with the definition of vectors. So vectors are a quantity with a magnitude and a direction. So what does this really mean? Let's say that you're driving in your car. This is going to be a top view in the north direction with a speed of 60 miles per hour. Now, um, this is like you're driving down the I-95 highway during Thanksgiving break to go back to your home or whatever. And this motion of your car would be a vector because it has a magnitude, right? But it also has a direction. This is different to what is known as a scalar, which is a quantity with only a magnitude, but it doesn't have a direction. A good example would be your temperature, right? Your temperature would only just be 29 degrees Fahrenheit or whatever the temperature is wherever you are. And this doesn't have a direction. This temperature is only a quantity. It doesn't really have a direction that the temperature is pointing to. Obviously, there is a positive and negative, but we can also say that is just a magnitude because it's how big the temperature is, right? So the temperature is a scalar because it doesn't have a direction that it's pointing to or going to. However, whereas the movement of your car is denoted as a vector because it has a magnitude and also a direction that the car is moving towards. Okay. Now let's talk about how to draw vectors. So when we're drawing vectors, we normally have a straight line with an arrow. This arrow right here that you see is really, really important because it's going to change the vector fundamentally. Um, if we have the same line, but the arrow is pointing the other way, these describe two different vectors. It's the same thing as if you're driving north at 60 miles per hour, that's different when you're driving south 60 miles per hour. If you're in Connecticut like I am, when you go north, that would make you go to Massachusetts. If you go to south, that's going to make you go to New York. So they're two different things, right? Um, if and the, When we look at these vectors, the tip of the vector is where these arrows are. These are called the tip of a vector. And the tail of a vector is the other part of the vector where it doesn't have an arrow. Those are called the tails of a vector, and pointy things with the arrows are the tips of a vector. And when you're drawing vectors, we normally denote vectors as v and u. You want to have these arrows up here because that's what's going to distinguish it between plain old variables that we know from algebra and vectors that do have direction. Those little arrows up there are what denote that this is a vector. You're dealing with a vector. That's what lets you know that that's a vector. Now, let's talk about how we want to split up vectors and talk about them, and mainly in components. So now we're going to draw an x and y coordinate system that we all love. And we're going to have this vector right here. And that's vector v. What it means to write vector components is that we're dividing this vector by how far it spans in the x-axis and how far it spans in the y-axis. So for this vector v, it spans 1, 2, 3, 4, 5, 6 units in the x direction, and 1, 2, 3, 4, 5, 6 in the positive y direction. So this vector, we can say, okay, it spans for 6 units in the positive x and 6 units in the positive y. the plus 6 in the x direction and the plus 6 in the y direction is what's called vector components. And you can describe the vector v in terms of these components if you write v equals 6 times I hat plus 6 times j hat. I hat is the unit vector in the x direction, which is this little thing right here, but obviously it's going to have to be moved up. That's I hat. And this little thing in the y direction, the unit vector in the y direction, that's denoted as j hat. Sometimes you'll see k hat, but k hat's not very common. But k hat, just for your reference, that's the unit vector in the z direction. And this notation here is called the unit vector notation. And there's another notation that you can represent this vector as, and that's called the magnitude uh, direction notation, where you can write v as, if you do some trig, 8.4 at 45 degrees above the x-axis, because that angle right there is 45 degrees if you remember your trig, and this is 8.4 if you do the Pythagorean theorem. That's about what you get. Um, so these are the two ways that we're mainly going to write vectors. I prefer the unit vector notation just because less numbers, more simple, and more concise. That's easier to recognize and it's easier to write and use. That's why I like that. But this is occasionally asked, so it's good to know how to do magnitude direction. But it's pretty simple, right? You just find the angle between the vector and the x-axis using some trig, and you find the magnitude by doing the Pythagorean theorem, right? So that's pretty simple. And you can go the other way as well. If you know the magnitude and the angle between the vector and the x-axis, all you need to do is do some trig. The x-hat direction would be the magnitude times the cosine of the angle, and the y-hat would be the magnitude times the sine of that angle. Now we're going to talk about how we're going to add and subtract and deal with these vectors. So let's just say we have two vectors, u, which is 3 times I hat plus 2 times j hat, and v is 1 times I hat plus 4 times j hat. We're going to talk about the case when we know these components because this makes life a lot easier. If you know components, right, you can just think of I hat and j hat as kind of variables, as stuff that you can't combine or do anything to unless we do some specific operations. And when we add and subtract these two vectors, we're just going to think of them as variables and combine like terms in front of the vectors to make our final product vector. So when we do u plus v, this is 3 times I hat plus 2 times j hat plus 1 times I hat plus 4 times j hat, which combines into 3 plus 1 times I hat plus 2 plus 4 times j hat, which becomes 4 I hat plus 6 j hat. Okay? And we can do the same thing with subtraction, right? Is 3 I hat plus 2 j hat minus 1 I hat minus 4 j hat. 3 minus 1 I hat, 2 minus 4 j hat, which is 2 I hat minus 2 j hat. We're not really going to consider when we're trying to multiply two vectors together because then we would need to multiply I hat and j hat. We don't really know what that is yet, so we're not really going to deal with it, but we do need to deal with it when we're multiplying a scalar to our vector. So when we're multiplying some scalar, let's say we're doing 3 times u, we can do the same thing as if we're doing algebra and write it as 3 times I hat plus 2 times j hat times 3, which becomes 9 I hat plus 6 j hat. So it's the same thing with how we would do algebra, just FOIL the equation and use the distributive property, and you get this cool vector here. Now, these three operations are relatively simple. They're easy, they're nice, they're neat, but they can only be done when you know the components of the two vectors. We're going to talk about when we don't know the components yet, mainly just adding and subtracting. Um, the multiplying here, right, if we don't know the components, just go u hat plus u hat, not u hat, u plus u, and for however many times you need to add u. So we're just going to talk about adding and subtracting here. We're going to take the two same vectors u and v for this purpose, right? That's u, that is v, and what we're going to do is that we're going to take v, and we are going to put the tail of v to the tip of vector u. And to get the final resultant vector, we're going to connect the tail of u to the tip of v. That right there is the vector u plus v. This is known as the triangle law. There's another law called the parallelogram law. I never used it. You just need to use this. This is really simple, neat. It's nice. You don't need to draw that many lines either, so it's really cool. If we think about u plus v in terms of components, right? It goes 1, 2, 3, 4 units in the x direction, and 1, 2, 3, 4, 5, 6 units in the y direction. So that vector becomes 4I hat plus 6 j hat, which is what we got up here. Okay? And when we try and do vector subtraction, we can think of subtraction in a slightly different way, but that's going to make our life pretty easy as well. So when we're trying to u minus v, right? We can think of this as u plus negative v, but how are we going to know how to do negative v, right? If we think of the components up there, negative v is just v times negative 1, which would be, if we think of the components of v up here, negative 1 I hat minus 4 times j hat, right? If we draw this vector here on the coordinate plane, that is our vector v, that is our vector negative v. So it's just vector v rotated 180 degrees about the origin. That's what gives us negative v. Now, to do this operation here, we just need to take negative v, connect the tail of that to the tip of vector u, and we have our resultant vector here, u minus v, which is, again, if you do components, it goes 1, 2 in the positive x direction and 1, 2 units in the negative y direction, which gives us 2 times I hat minus 2 times j hat. Now, this is how you do addition and subtraction of vectors when we don't know necessarily the components, and then we only know the drawings. Today we talked about what vectors are, how to draw vectors, how to denote the components of vectors, and if we don't know the components, and also how to add and subtract vectors when we know components and when we don't know components. Thank you for listening and watching this video. Stay tuned for the next one where I will talk about kinematics.